On the back of each Soundweb London DSP device are control inputs and logic outputs. If we look in the help file for London Architect, and then search for the installation guides, about 2/3 of the way down the installation guide, we'll find information on the control inputs and logic outputs. There are 12 control inputs and 6 logic outputs. These can be used with potentiometers, switches, buttons, LEDs, very lightweight reed relays, things of that nature. To wire these objects up, for the control inputs, there are 2 different ways to use them. One is called 2-wire mode, one is 3-wire mode. In 2-wire mode, you use switches, 47K log taper pots, or resistor ladder networks, based on a chart I'll show you in a little bit. You only have to wire 2 wires to the device. That's why it's called 2-wire mode. If you're wiring up a pot, you take the common from the device to one end of the trace and the control input to the other end of the trace and the wiper. In 3-wire mode, you still wire the common to one side of the trace. You still wire the control input to the wiper, but the other end of the trace is wired to the R, or reference voltage output, on the device. When doing a resistor ladder in 3-wire mode, use all 1K resistors. And when using a standard switch, you need to wire a resistor in parallel with one leg of the switch. Programming London Architect to use these control ports is very simple. We go to the design tree and locate our device. In that device, under the configuration we're using, we find the control ports. If I want this master gain fader to be on control input 1 with a potentiometer to control the volume, I drag it over, drop it in place. I have a choice of analog input or up-down pair for the mode. If I select analog input, this control input will be looking for a variable resistance to control the volume. In other words, a pot. If I select up-down pair, then this control port and the next control port in line will be looking for momentary contacts for up volume and down volume. Let's select analog input, hit OK. I'm now mapped to a single control port. I can see it listed. Plug in my potentiometer, it'll work. If I right click, I can disconnect. Let's map it again. This time we'll select up-down pair, and you'll see it maps to 2 ports. The first port is a momentary contact for volume up. The second port becomes a momentary contact for volume down. If I grab the mute button, drag it over to input number 4, I again have several choices for how to assign that state variable to that control port. The first choice is direct action. Direct action means when the contact is closed, that button is on. In this case, it would mute our audio because it's a mute button. Direct action inverted means when the contact is open, that button is on. Toggle action means every time I close that contact, I'll toggle the value of the state variable. It'll go from off to on to off every time I close the contact. Assigning a source selector to a control input is similar in some ways to assigning a fader. When I drag that source selector over, I have a choice between multi-state and analog input. These 2 choices are identical to the analog input and up-down pair presented when placing a fader. If I choose analog input, I'm assigned to a single control port. That control port is looking for a resistance value, and different values are mapped to different selections on the source selector. If I drag that same selector to input number 4 and choose multi-state, it maps it to one control port for every possible state on the source selector. A momentary contact on input number 4 would set the output to none. Momentary contact on input 5 would set it to source 1, source 2, source 3, source 4. If we go back to the help file and look under control inputs, we'll find a very important chart. When assigning a source selector to a control input, it's important to know what values of resistors to use when building the resistor ladder. The values to be used will be determined by the number of states in that source selector. The value for selection 1 isn't always the same. It changes depending on how many total states there are in your source selector. The values for those resistors are listed on this chart. When using 3-wire mode, there is no chart to consult because every resistor in the resistor ladder is a 1K resistor. We also have 6 control outputs. The control outputs are 0 or 5 volts. If I grab a fader, drag it over to control output number 1, it doesn't work. The control outputs are 0 or 5 volts, not 0 to 5 volts. You can only assign discrete state variables with 2 states to a control output. In other words, buttons, basically. If I grab this mute button, drag it over, I have 2 choices, normal or inverted. If I assign it normal, that means when this button is on, that output will be 5 volts. When the button is off, the output is 0 volts. The outputs are internally current limited, so they're designed to drive LEDs with no additional current limiting resistors needed. Plug them in, they work just fine. It may also be tempting to take a source selector, drag it to a control output, hoping to get one control output for each possible source. Unfortunately, that also doesn't work. If you need that functionality, it can be accomplished with logic. When using control ports, the final thing to be aware of, the 2 modes, 2-wire mode, 3-wire mode. If you right-click on the device and look at the default control panel for the device, that's where the button is located to switch between 2-wire and 3-wire mode. As long as that button is off, the device is in 2-wire mode. Turn it on, the device is in 3-wire mode.